concrete. So what it looks something like this. So basically it works on the principle that there is a steel mass provided under inside the casing of the rebound hammer. When this steel mass is subjected to a height and then drops, it gives a rebound depending on the hardness of the hardness of the surface which is comes in the contact with the hammer. So it gives a parameter known as the rebound number, and this rebound number is directly correlated to the compressive strength of the concrete. So with the help of the rebound number, we can determine the strength of the concrete, compressive strength of the concrete. So in this, we need require a rebound hammer, the abrasive stone, and the test anvil. The test anvil is used to calibrate the rebound hammer, and abrasive stone is used to remove the irregularities on the surface that we need to test. The testing specification is IS 13311 Part 2 1992. So we need to select the test specimen, and it should be the test specimen should be at least 100 thick and fixed within a structure. It is a requirement. Then if if there is any plaster surface, then you should remove the plaster surface so that the hard concrete surface should get exposed, and you have to perform test on that particular hard surface. Other than that, if there is any honeycombing, scaling, or any porous surfaces, you should avoid the testing on that particular surfaces. If the surface is undulated, then you should use the abrasive stone and the smoothen the surface out, or to remove the loose mortar. Then test area shall be at least 150 in diameter. Okay, so what you have to do, you have to clean the surface, you have to clean the test area, then simply hold the instrument firmly so that it is perfectly perpendicular to the surface. Then you have to gradually push the hammer, and after until you hear a distinct crash sound, which signifies that the hammer impacts. So the hammer will give a reading directly. You have to record this reading. That reading is the rebound number. Around each point of the observation, at least 6 readings should be taken. And if you want to get much reliable result, up to 20 readings you can take. Now, during the during the during the during the conduction of the test, if the surface breaks down, or if there is any damage arises in the surface, then you have to discard this particular reading. It might be due to the improper compaction. So this surface, and there is a particular relationship based on the property of the surface, whether the surface is dry or the wet. There is a relationship exists between the compressive strength and the rebound number. So based on the rebound number, you can directly predict the compressive strength of the particular concrete without performing any destructive testing. So points taken in consideration: the surface should be smooth, so you have to grind the surface with the abrasive stone. The instrument should be kept perpendicular to the surface. The point of impact should be at least 20 away from the edge. Also, you should avoid if there is any reinforcement, steel reinforcement or air voids, you should avoid that particular area. Okay. Then it should be periodically serviced, and its calibration should be properly maintained. It is quite essential. And the final test is ultrasonic pulse velocity test. So it doesn't give the compressive strength, but rather it gives the quality of the concrete in consideration. So it is based on the simple principle that the uh, comparatively higher ultrasonic pulse velocities are obtained when the quality of the concrete is dense, homogeneous, and uniform. So basically, what happens if this is your specimen and you have applied a transducer here and another transducer here, and if there is no cracks in between them, then the ultrasonic pulse will travel directly within these transducers and follows the shortest path. So time will required for traveling from point A or transducer A to transducer B would be very less. However, if there is any crack in between, then wave have to travel a much longer distance between A and B point, and time must be higher. So the velocity, which is distance upon time, would be lower. So based on the velocity, we can predict whether the quality of the concrete is good or bad. So you have, first thing you have to consider is the frequency of the transducer, which directly depending on the path length. So how much thick your specimen is, or how much thick your structural member is, based on the thickness of the structural member, or based on basically the path length of the structural member, you have to uh, determine the natural frequency of the transducer. So this is the ultrasonic pulse velocity machine. This is the control unit. You can set the frequency from this array, which these settings. You have two attachments here. First one is the uh, transmitter transducer. Second one is the receiver, and you can connect use these transducers into these points. So what you have to do, you have to select the most suitable test point of the on the material which you need to test. Now you can calculate the ultrasonic pulse velocity. You can calculate the time in one of the three possible arrangement. This is the direct or cross transmission, which is usually followed if the thickness of the structural member is low. So you can perform the testing directly using the arrangement, and it gives the most reliable result. Then this is the semi-direct transmission, and this is the indirect or surface transmission. So although uh, it also gives the reliable results, but the reliability of this mode is best among the three modes. Okay. So you have to connect the transducer to the sockets marked between transmit and record, and you have to switch on the pulse velocity meter. The ultrasonic pulse impinges on the surface of the material, and its energy is propagated to the right angle. So that's why this is the best arrangement or direct arrangement. Now it is you have to select the most efficient path length. So based on the path length, you also decide the what would be the, as I have already told you, the frequency of the ultrasonic pulse velocity. So up to the path length of 400 mm, or rather the thickness of the structural element is, if thickness is up to 400 mm, then the path length can be selected, the frequency can be selected as 0.1. Now it is essential that the contact between the surface of the structure member and the transducer should be proper. So in order to ensure that, you also need to apply some couplant to it. The couplant can be in the form of the petroleum jelly or the grease. So you have to apply a thin layer of the grease or couplant between the surface and the transducer, so that their connection is efficient, and you should get the proper readings. Now based on the when the ultrasonic pulse beam is emitted from the transmitter and received from the receiver, the time is usually reflected in the display screen. So after, since we have already fixed the velocity of the uh, we have already fixed the velocity of the beam, and we have calculated the time. We have already fixed the path length. We can calculate the time. We can calculate the velocity of the pulse velocity, and based on the pulse velocity, we can determine the quality of the concrete. So if the pulse velocity is greater than 4.5 kilometer per second, we can say the quality is excellent. Okay, but if it is less than 3 kilometer per second, then quality is doubtful. Now it should it is essential that the concrete surface should be smooth. So similar to the rebound hammer, you have to with the help of the abrasive stone, clear off the surface so that the proper contact should be maintained. Other than that, in case of the reinforced concrete, you need to take readings in the places where the reinforced bars are not located, because usually the velocity comes out to be higher because reinforced bars are much denser than the concrete. So you will get the improper reading, or rather high reading as compared to the plain concrete. Then there is a minor influence of temperature as well. So at a temperature between 30 to 60 degree, there can be reduction in the pulse velocity up to 5%. Okay, but below the freezing temperature, the free water freezes within the concrete, so the pulse velocity increases up to 7.5%. So you have to take this consideration also. Other than that, you have to take the multiple readings so that you can report the average reading, because concrete is inherently heterogeneous in nature. So you have to take the consideration of heterogeneity also in the consideration. So